High availability is a critical concept in system administration and infrastructure management. It refers to the ability of a system to remain operational for extended periods, even in the face of hardware or software failures. This is achieved by creating redundant systems that can take over operations seamlessly if one system fails. For businesses, downtime can result in significant financial losses, reputational damage, and a loss of customer trust. Pacemaker is an open-source cluster resource manager that provides high availability capabilities to Linux systems. It works in conjunction with CoroSync, a messaging layer that enables communication and coordination between the nodes in a cluster. This tutorial will guide you through the steps of setting up a basic high-availability cluster using Pacemaker and CoroSync on Linux. Before we dive into the configuration process, let's ensure that you have the necessary prerequisites in place. First, you will need at least 2 Linux servers with identical or similar hardware and software configurations. These servers will form the nodes of your high-availability cluster. You should have root access to both servers to install packages, configure services, and manage system settings. The servers should be connected to a network and have static IP addresses assigned to them. Ensure that the servers can communicate with each other over the network. You should be able to SSH into both servers as the root user. Once you have these prerequisites in place, you are ready to proceed with installing Pacemaker and CoroSync. With your servers prepped, the next step is installing the necessary software for high availability. This primarily involves Pacemaker, our cluster resource manager, and CoroSync, responsible for communication within our cluster. On both of your Linux servers, execute the following commands to install Pacemaker and CoroSync. This single command fetches and installs both packages along with any dependencies. Once the installation is complete, we need to enable the necessary services to ensure they start automatically when the system boots. Use the following commands and... With Pacemaker and CoroSync installed, our next step is configuring CoroSync, the communication backbone of our high-availability setup. CoroSync requires a configuration file that defines how the nodes in the cluster communicate with each other. Execute the following command on both nodes to generate the configuration template. This command creates a file named in the directory. Next, open the file in a text editor and locate the and parameters. Update these parameters with the IP address of the network interface that your servers will use for cluster communication. Ensure that both nodes use the same IP addresses for these parameters. With CoroSync configured, we can now start the CoroSync service on both nodes and verify that they can communicate with each other. On both nodes, start the CoroSync service using the following command sudo systemctl start CoroSync. To verify that CoroSync is running and that the nodes can communicate, you can use the following command on either node sudo CoroSync quorum tool s. This command displays the status of the CoroSync cluster, including the nodes that are part of the cluster and their current state. You should see both of your nodes listed as member, indicating that they are connected and communicating properly. With CoroSync running smoothly, we can now turn our attention to Pacemaker, the brain of our high-availability setup. Just like we did with CoroSync, we need to start the Pacemaker service on both nodes. Use the following command on both nodes, sudo systemctl start Pacemaker. To verify that Pacemaker is running as expected, you can use the following command on either node, sudo pcs status. This command displays the status of the Pacemaker cluster, including the nodes that are part of the cluster, the resources that are being managed, and their current state. You should see both of your nodes listed with a status of started, indicating that Pacemaker is running and ready to manage resources. Now that we have our high availability foundation set, it's time to define the resources we want to manage. These resources could be anything from web servers to databases or custom applications. Before we can configure resources, we need to authenticate the nodes in the cluster. This ensures that only authorized nodes can join and manage resources in the cluster. On one of the nodes, execute the following command, sudo pcs cluster auth, node 1. Node 2, uroot p, your _root password. Replace and with the host names or IP addresses of your nodes. Replace with the root password of your nodes. This command will prompt you for the root password of each node. Once the nodes are authenticated, we can start configuring resources. For this tutorial we will configure a simple Apache web server as a cluster resource. On one of the nodes, execute the following command to create a new resource group named web server, sudo pcs resource group add web server. This command creates a logical grouping for our web server resources, making management more organized. Next, we will create a virtual IP address resource that will be assigned to the active node hosting the Apache web server. Execute the following command on one of the nodes. Sudo pcs resource create VIP OCF heartbeat ipattern2 IP =192.168 1.100 cider underscore netmask =24 op monitor interval =30s. This command creates a new resource named VIP of type ipattern2 provided by the heartbeat resource agent. The parameter specifies the virtual IP address that will be assigned to the active node. The parameter specifies the netmask for the virtual IP address. The option configures Pacemaker to monitor the status of the virtual IP address every 30 seconds. Finally, we will create the Apache web server resource and add it to the web server resource group. Execute the following command on one of the nodes. Sudo pcs resource create web server OCF heartbeat Apache config file =etc/apache2/apache2.conf op monitor interval =30se group web server. With our cluster resources defined, we can now use Pacemaker's command line interface to manage their state and behavior. To start the web server resource group, use the following command sudo pcs resource enable web server. This command instructs Pacemaker to start the web server resource group, which includes the virtual IP address resource and the Apache web server resource. Pacemaker will determine which node is best suited to host the resources and start them accordingly. To stop the web server resource group, use the following command, sudo pcs resource disable web server. This command instructs Pacemaker to stop the web server resource group. To move the web server resource group to a specific node, use the following command, sudo pcs resource move web server node underscore name. Replace with the host name or IP address of the node you want to move the resource group to. The final step is to test the high availability setup to ensure that everything is working as expected. To test the failover capabilities of our setup, we can simulate a node failure by stopping the Pacemaker service on one of the nodes. On the node that you want to simulate the failure on, execute the following command, sudo systemctl stop pacemaker. This command will stop the Pacemaker service on that node, triggering a failover event. Once the failover event is triggered, Pacemaker will detect that the node is no longer available and will automatically start the web server resource group on the other node. The virtual IP address will be moved to the active node, ensuring that the web server remains accessible. To verify that the failover was successful, you can try accessing the web server using the virtual IP address. Once you have verified that the failover was successful, you can start the Pacemaker service on the failed node to bring it back online. Congratulations! You have successfully set up a basic high availability cluster using Pacemaker and CoroSync. Your Linux services are now more resilient and less prone to downtime due to single points of failure. However, setting up a high availability cluster is just the first step. Maintaining a healthy and reliable cluster requires ongoing monitoring, maintenance, and troubleshooting. Here are some essential tips for maintaining your high availability cluster. Monitoring. Implement robust monitoring solutions to keep track of your cluster's health, resource utilization, and performance. Utilize tools that can proactively alert you to potential issues. Regular updates. Keep your systems updated with the latest security patches and software updates. Regularly update Pacemaker, CoroSync, and other relevant packages to benefit from bug fixes and performance improvements. Log analysis. Regularly review system and application logs to identify any errors, warnings, or unusual activities. Log analysis can provide valuable insights into the behavior of your cluster and help you diagnose issues. Documentation. Maintain comprehensive documentation of your cluster configuration, resource definitions, and maintenance procedures. This documentation will be invaluable for troubleshooting, knowledge sharing, and future reference. Testing. Periodically test your failover scenarios to ensure that your cluster behaves as expected. For further exploration and more advanced configurations, refer to the official Pacemaker documentation and other online resources.